In one of our previous lessons in the Pragmatic REST APIs course, we implemented support for offset-based pagination. Typically, when someone is talking about pagination, this is the default pagination approach that they are thinking about. However, in this lesson, I'll show you how to implement cursor pagination, which is a more advanced and more complex pagination approach. It's suitable for some situations. I'm going to discuss what they are, but it also has some drawbacks that you should be aware of when considering which pagination approach to implement. So let's jump into the code and I'll demonstrate how to implement cursor pagination. I'll start from the entries controller, and it's here that I want to add support for cursor pagination. And what I'm going to do is take the existing endpoint for fetching the entries and just create a copy. So let's add the copy below, and then we need to update the name of our method. So I'll call it getEntriesCursor for lack of a better name, and I will expose this as a new URI on our API surface, and the endpoint is going to be entries/cursor. Then we need to make a few adjustments. Let's start with the query parameters. I'll go into the old object that I have, the entries query parameters, and I'll create a copy. So this copy will be called entries_cursor query parameters. I'll move it into its own file, and then let's consider what we need to update here. With cursor pagination, we want to be controlling the sort direction. So I'm going to omit the sort parameter and replace it with an opaque value that's going to represent our cursor. The cursor is going to represent an index pointing to the first record in the next page of results that we should return when calling our new API endpoint. You'll see how this looks like in just a moment. We no longer need a page number, and the page size is typically not used with cursor-based pagination. Instead, it's called a limit. So let's define a limit, and I will leave the default value of 10. Now we need to use these query parameters in our new API endpoint. So I'm going to make an update, and you will see that anything that was referencing the sort field is no longer working. So let me omit this. I will also remove the sort mapping provider, the method call that was referencing it, and I'll remove the reference to the apply sort method. Now when it comes to pagination and fetching the total number of records from the database, this is something that's also not needed for cursor pagination. So we are already sparing ourselves one database request. We won't be doing a skip operation. Instead, we're going to do a take, and we can pass in the query limit parameter. The next problem is, what do we return as the API response? A pagination result doesn't really fit the structure for a cursor pagination response, so I'm going to create another one that's going to be more generic, and I'll define it in the common folder for my DTOs. I'll call it just a collection response, and it's going to be an abstract class, and I will implement the iCollectionResponse interface and also the iLinksResponse interface. So let's define both of these interfaces, and we get the list of items and our hypermedia links. So let's go ahead and use this in place of the pagination result. I can still leave the expandable object because I want to support data shaping, and then I'm going to omit the pagination fields because I no longer need them. Let me close this down, and then let's consider what we want to do here. We need to define a cursor that's going to allow us to represent something like an index pointing to a record in the database that represents the next entry from which we want to take a given number of records. Now, in the default case, we're just going to take the records from the start of the table. All of our filters are defined beforehand, and we need to guarantee a sort order. So this is the first important step when it comes to cursor pagination. Because I want to be returning the entries for representation on the user interface, I want to sort them in descending order based on the entry date. Now, another requirement for implementing cursor pagination is that the value that you use for the cursor should be unique. And the date is definitely not unique. We could have multiple entries with the same date. So we need to sort by an additional component to make this work. So for example, I can sort based on the identifier of my entries, and because I'm using a version 7 UUID, which is sortable by the timestamp, I can guarantee that the records are going to be sorted in a unique sort order. First by the date in descending order, and then by the ID value, which is unique, also in the descending order. Another option to consider is a created at timestamp, but I find the ID value more suitable for this use case, so that's what I want to use. So we have our sort order defined, and then we fetch our one page of records. But we also need to figure out if we have a next page. And with cursor pagination, we can solve this by adding 1 to the limit value and then checking if we get back more results than we have as the limit. So I'm going to create a variable that I will call hasNextPage, And this is going to be true if the number of values that we get back from the database is greater than the query limit. This specific value is what I'm going to use to define the cursor. So I'll create a temporary variable that's going to represent the cursor of the next page, but we need a way to represent this data structure. It's going to depend on our date and the identifier of the entry, and you have a couple of options. You could return these values in their raw format back to the client, but this adds structure to the cursor, and it's something that you should avoid in general. It also couples the current implementation to the cursor value, whereas the cursor should be completely opaque to the client, and the client doesn't need to know what it represents. So I'll create a new object inside of my entries folder where I have all the other DTOs, or to be more precise, I'll create a new type, which I'm going to call the entry cursor DTO. Let me drop in the implementation for this, and this is what the entry cursor DTO will look like. It's going to accept an ID and a date only value, and this is going to represent my cursor. Then I'll expose two static methods. One is going to be called encode, where the parameters are the ID and the date only field, and I'll create a cursor, serialize it into JSON, and then perform a base64 encoding. Now I'm using the base64 URL encoder class that we have in the Microsoft Identity Model Tokens namespace, and this is going to perform a URL safe encoding in base64 format. In the other direction, I'll create a decode method that accepts a cursor value, tries to decode it using the base64 encoder, and calling the decode method, and this should give me back my JSON string that I can deserialize into my object. So now I have my cursor DTO. How do I use it? Well, back in the entries controller, if we have a next page of results, then I can go ahead and grab the last entry DTO from the entries collection that we are getting back from the database. Remember that the last one is the one that we are using to fetch the cursor. And we're only doing this if we're getting more records back than the query limit. So I'm going to call entry cursor DTO, encode the identifier and the date of this last entry, and I'm going to remove it from the entries before I perform data shaping. So I'm ensuring that I always return at most the limit number of records back as the API result. Let's take care of hypermedia, and I'll create another method that I will call create links for entries cursor, and it's going to accept my query and the next cursor value that we have as a variable. Now all we need to do is to create this method. So let me go to the bottom of my controller, and this is where I have the create links for entries method, and I can use it as the baseline for the implementation of my new method. Let me call this create links for entries cursor. We're going to accept the entries cursor query parameters, and the one argument is going to be a nullable string representing the next cursor. The self-referencing link is going to point to our new endpoint, so is the one pointing to the next page. We won't need a previous page link, so I can remove that.